So, learning targets for today as we go through our confidence intervals for proportions is we're going to use a four-step process to construct and interpret a confidence interval for a population proportion. Tomorrow we're going to do this exact same thing, but we're going to be doing for the population mean. So it's a four-step process. It's really just a couple things change between today and tomorrow. It's like, hey, we're doing means and we're checking a different condition as we go forward. Then the other part of today's lesson is determining the sample size required to obtain a certain confidence interval based on a certain margin of error. So we did that in the last chapter where they said, hey, we wanted to have this occur. What did we need to solve for? What did n need to be? And that did a lot of inverse operations. So we're going to do that same thing again today as we work through the problem. And then we'll go on to the next section after that. So taking everything we've done Friday and yesterday, putting it all together, that's what this first part is. When we're doing the four-step process for confidence intervals, what we want to do is we want to do some state. We're going to do a state, plan, do, conclude. That's our little four-step process. My AP kids, what they go through and do is they write those four words down. Now they have them spaced out, but they write them down and they're going to say, oh, state. And then they're going to write their little statement. And then they're going to go say, my plan is to do this. And we show a nice little crisp way to put it down there to try to maximize the amount of points they can get on the problem to make the reader be able to find it and interpret it really quickly is what the goal is as we're doing those things. We state the parameter you want to estimate. So is it going to be the true proportion? Is it going to be the true mean? That's what we're going to be doing for the parameter. And then also what confidence level are we doing it at? In the plan, we identify the appropriate inference method. So are we doing a Z interval for proportions? That's what we learned yesterday because we found Z star and then we did the formula. And then we're also going to check the conditions. If the conditions are met, do we meet the conditions that we learned about? Is it random? Is it, do we meet the large count? Is NP hat greater than 10? Is N times 1 minus P hat greater than 10? That's what we mean by checking conditions. And then the do stage, if conditions are met, then we get to go ahead and perform the calculations. And then we interpret it. And so interpreting is back to what we did on Friday. We're blank % confident that the interval from this number to this number captures or contains the true proportion of blah, 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 blah. Okay? So we get to just jump right into a problem and just walk through the process. So the General Society, the GSS, is a survey administered by a random sample of adult Americans. And so I'm going to go ahead and underline. I always like when I read, I like doing that. Random sample. Okay. One question on the survey was taken all together. How would you say things are these days? Would you say that you are very happy, pretty happy, or not too happy? Of the 2,500 respondents, 786 corresponded that they were very happy. Construct and interpret a 90% confidence interval. Woo, sweet. So with that in mind, my state. Here's the first part, the statement. We will construct it says 90% confidence interval. For P, which equals, what is P equal? It is the true proportion of adult Americans who responded, quote, very happy. All right, there's my little statement in the very first part. Hey, we're going to construct a 90% confidence interval for P, which is the parameter, the population parameter, P. which is the true proportion of adult Americans who responded, sorry, I left off the D, responded very happy. Nice, short, sweet. And then we're going to use that when we go into our conclusion after we say that, we're 90% confident. After we talk about the interval, we can just use that, the true proportion of adults who are responded very happy. So we get to regurgitate that portion in the statement phase in our final answer. Okay, so we don't have to come up with a really big, crazy crafting at the end. So my plan, we are going to do a one sample Z interval for proportions. If conditions are met. That's my plan. So let's go ahead and check the conditions. We have two conditions. There's really three, and we'll talk about it here. My first condition is at random, and we practiced that yesterday. And I underlined it up there. We said we had a random sample of adult Americans. So random sample of adult Americans. Remember, sometimes they'll just say that SRS, a simple random sample. So say we met the random clause, sweet. The next thing I got to do is the large count. Large count, that's where is NP hat greater than or equal to 10, and is N times 1 minus P hat greater than or equal to 10. Now, we showed this in our activity yesterday and so forth. It's a matter of taking, we know what P hat is. I'm going to do this off to the side here. P hat is 786 over 2538. That's my P hat. Now, we know it gets pretty messy. All right, as we're doing things, when we start showing, is it bigger or not? So I'm going to do it once. 2538 times 78 or 786 over 2538 greater than or equal to 10. What do the 2538s do? Don't they cancel? Didn't we show that those two things cancel? So I just get 786 greater than or equal to 10. So we met there. So on the other side, to speed it up, I'm going to think about, okay, what is 1 minus, or what is the opposite? So what is 2538 minus 786? So that's really 1752. And again, I got that number saying 2538 minus 786. That's how I got that number. So we met the condition for a large count. We're also supposed again, the book didn't focus on this, but we're also supposed to check the 10% condition because we're not doing replacement. And that's for the independence part. Is 2,500 respondents less than the 10% of the total U.S. adults? Yeah. I mean, when we think about how many U.S. adults are there, probably about 200 million. Okay, so with that in mind, 2,500 is definitely less than 10% of the total number of U.S. adults there are. So we meet the 10% condition. And that's what some of your college statistics may have you check as a third condition. 2,538 is less than all U.S. adults. We know there's going to be over some 100 million worth of U.S. adults. We are definitely well underneath that once we meet the independence clause, is what that's called. So now we're ready to do our confidence interval. So now in the do stage, we're going to perform our one prop Z interval. So we're going to do a one prop Z interval. Now, the prop is an abbreviation for proportion. We have one proportion that they're giving us, 786 over 2538. So, based off of our formula yesterday, it is p hat plus or minus z star times the square root of p hat times 1 minus p hat over n. That was the formula we used yesterday. I'm going to show you this once, this long way, then I'm going to show you the faster way, how we can do the rest of the stuff. And then it'll be your choice from here on out, which way do you choose. So this would be, as I start filling in, 786 over 2538, plus or minus, I have some big long z-star decimal, square root of 786 over 2538 times 1752 over 2538 over 2538. Now, my z-star, we are doing a 90% confidence interval, so 1 minus 0.90 divided by 2. So that's 0.10 divided by 2, which is 0.05. That is my area. And now we're ready to use an inverse norm with an area of 0.05. My mean is 0. My standard deviation is 1. Remember, we're doing a z, which means it's standardized, which means that my mean and my standard deviation are 1. So I'm going to catch up in the calculator here, and I'm going to do this all on the main screen calculator. Let me get rid of this thing here. So boom, 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 boom. Again, you can get ahead of me of getting z-star. All right, so there we go. So with that in mind, second VARS inverse norm option number, which is number 3. My area is 0.05. Leave the rest alone. Hit enter, and I get 1.6448536. That's enough. That'll get us accurate to the 4th decimal easily, using that many. We can use the extra 2 numbers. We don't need to. So now I have my formula. Now I'm going to start with the square root part, get that, and then start working my way to the left, simplifying. So bear with me as I start doing this with the calculator. You're going to like the next way I'm going to show you after this problem. It makes our life a lot easier. All right, making sure I typed all those numbers in right. That looks good. All right, so I hit enter. So we now have 786 over 2538 plus or minus that long decimal for the z-star. The square root part becomes 0.00917784888. In the calculator, I'm just going to go ahead and take that decimal and multiply it by our 1.6448,536. And that tells me that that part becomes 0.0150962. That's enough for decimal parts. So what is 786 divided by 2538? That's 0.3096926. And then now I'm going to start just saying, okay, let me add those 2 decimals together. So take those 2 decimals, so that plus that previous one there. So my upper bound is 0.3248. My lower bound, I am going to take that answer and subtract the 0.015. And my lower bound would be 0.2946. So there's our confidence interval, which is what we focused on yesterday calculating. Now we get our nice little write-up. So we get to say, all right, this is what we did on Friday. We are 90% confident that the interval from 0.2946 to 0.3248 captures the true proportion. That's what we were trying to find, the true proportion. The true proportion of U.S. adults or adult Americans, U.S. adults who responded very happy. All right. And again, that's it. There's the whole process. Everything we've been doing in 3 separate sections, all wrapped up in one nice little contained format. Okay. Again, this is what like my AP kids, they have to do. And if they can do this successfully, not make any goofy mistakes, then they'll get full credit for the problem. They'll get 4 out of 4 for the problem. If they don't do a statement phase, they're automatically a 3 out of 4. If they don't check the conditions, there's another point off. So it's almost like 1 point for each of the different parts is what they get for this thing here. All right, so that's why I try to tell them. I know it's a pain in the butt, but it's a nice little template to kind of fill out. And the more we practice doing it that way, then we get more successful on it for the AP exam. Now, you ready to learn a faster way to do the confidence interval part? Yeah, I see Alex over there shaking his head. All right. So as I scroll my screen over on the sides, and I started giving this a little clue right there. 1 prop Z interval. And I'm going to do a split screen so the video gets to see this one too as I do this. So as I bring up the Calc 84 app, it'll be there so that people on the video can see it. So with that in mind, I want you to press Stat. An arrow once to the right, and you see Calculate. And we've been in the Calculate stuff all the time. Okay, we've done one var stats, a linear regression, and so forth. I want you to arrow over to the 3rd column. This is the column of stuff. This is the tab of stuff we're going to be hanging out for the next month. All right. We'll use the second vars whenever we need an inverse norm for a z-star. Okay. But when we're trying to find our confidence intervals, we're going to be using this part to do it faster. Now, anything that says the word test, that's a hypothesis test. That's the next chapter. Okay, so you've got to be really careful because you notice there's a lot of things that say Z and T's in there. All right, a test means a hypothesis test. And an interval means an interval. Now, as you scroll the screen down, be very careful. Because this is where if you go ahead of me, you may not realize something. When you see options 7 and 8 that say Z interval and T interval, those are based off of doing means, meaning they gave you like X bar. And we're trying to predict or say something about mu is what we're trying to talk about. That's the next lesson. Okay? The 2 sample means that you're trying to find the difference between 2 things. So let's say I did a survey in here and I wanted to find is there a difference between males and females for that same survey? Very happy, whatever. So a 2 sample means when you're comparing 2 things together, 2 different samples together. They may have total different numbers. Do we have the same number of boys and girls in this class? No, we don't. So that's okay. All right, but we're going to say, hey, is there a difference in the proportion of whatever? So we are mainly focused on is option A. That's the one we want to use. We want to use a one prop Z interval. So I'm going to press enter. And now all we have to type in, 786 was the successes. That was the top of the fraction. Bottom of the fraction was 2538. And then we put in our confidence level, which happened to be 0.90. Go down to calculate, hit enter, and on our screen, voila. There's our, as I scroll over so people on the thing look, we'll notice that we match when we round to the fourth decimal place, which makes things go a heck of a lot faster as we're trying to do that calculation part, the do phase. Okay? Still got to do in the four-step process, we still got to do all that other stuff. But now the calculation part, the do stage, gets a lot faster. And so for like my AP kids, all they have to write down in the do stage is they get to say one prop Z interval. And then they say, all right, my X is 786, my N is 2538, and then my C level is 0.90. That's all they have to show for work. And then the answer. They don't have to show the formula. They can if they want to and stuff, but that's what they have to show, for the work aspect of getting the answer. Okay? They just ask for common courtesy is to label what 786 and N are and stuff. Just don't throw down 786 and that stuff. Is what are they? What do they represent? Same thing we did for the normal CDF stuff when we said it was the upper bound and the lower bound stuff. Okay? So, now, let's do the problem. And I'm going to highlight the, we should have some time. We can probably do a bunch of these, but let's do the problem. So Letitia wants to estimate what proportion of her school seniors plan to attend prom. She interviews a simple random sample of 50 of the 750 seniors. That's a huge senior class, 750. All right, that's a big senior class. She interviews, that's almost like one of my high school buddy who lives in Houston. His daughter is going to a high school, and there is roughly 4,000 to 5,000 kids in the high school. So about 1,000 per grade level. I mean, that is a stinking huge high school. We just have 1,450 in our school. So you're looking at about, take our whole school, multiply it by 4, and that's what they got almost in their thing. We want to do a 90% confidence interval for the true proportion of all seniors at the Letitia High School who plan to go to prom. All right, so let's go ahead. Again, if you can type or write faster than me, the four-step process, go ahead and get ahead of me. I'm going to write it down here in its entirety. Statement, we will construct a 90% confidence interval for P, which is equal to the true proportion of seniors who, I wouldn't say will, we're going to use the word plan on attending the prom at Letitia's high school. Again, that last sentence, that last part, the true proportion of seniors, we're going to use that again in the final part of our interpretation phase after we talk about the confidence level, the confidence interval. So our plan is to calculate a one Let's go sample. I like that better. Because we got one sample is all we're dealing with. A one sample Z interval for proportions. If conditions are met. Again, all we have to worry about is now the random clause and large count. So random, SRS of 50. There is an SRS of 50 seniors. Large count. This is the n p hat greater than or equal to 10 and the n times 1 minus p hat greater than or equal to 10. 36 is greater than or equal to 10, and then 1 minus would be 14 greater than or equal to 10. Okay, it's great when they give us counts. When they say, hey, 36 of them, 36 greater than 10. And then what's 50 minus 36? 14. 14 is greater than or equal to 10. If we do percentages, then we get to do the percentage times the sample size, and then 1 minus the percentage times the sample size. But this one, since they're giving us as actual numbers, we don't have to convert it. So the conditions are met. We do actually get to say we meet the condition for the independence, because is 50 less than 10% of 750? What's 10% of 750? Yeah, 75. Yeah, so 50 is less. So we did meet that condition too if they were asking us to check all three. So now in the do phase, and we're going to use the calculator, we're going to do a one prop Z interval. My area. The nice thing is since this is 90%, we've already done that on the previous problem, so that we know our area is going to be 0.05. Actually, let me take that back. I'm already thinking about getting inverse norm. I don't need inverse norm for that thing. In our calculator feature, my bad, we just have to type in, okay, what is X? X is 36. N is equal to 50. And we're doing a C level of 0.90. That's the beauty about using this, this process is I don't need to do all that stuff. So as I go into my calculator, we're going stat over to tests up to or down to one prop Z interval. Go back up there and let's change our stuff. And I am doing 36, 50. And I get to leave the confidence level alone and hit enter. And I find on there that it is 0.61556 to 0.82444. Now, most likely your book's going to like it to 3 decimals. So, and your online assignment, so 0.616 to 0.824 is probably what they want you to type in as you're doing it. Just do it accordingly. Now we're ready for the wrap up. We are 90% confident that the interval where did I put it at? Where'd you go? Ooh, there we go. At the interval from 0.61556 to 0.8244 captures and this is where I get to use the part about the true proportion of seniors who plan on attending her prom. The true proportion of seniors who plan on attending Letitia's high school prom. Okay. Nice, short, sweet. Again, the more we practice it, it gets easier, especially with the phrasing. But the math got a lot easier there using that feature in the calculator. Okay. Again, the reason why we have it the other way that we did yesterday, because I do like having the true setup of the thing of what is the formula, and also because some of you, as you go off to college, some of your professors may not let you use the calculator, and you have to do it by formula. So I always try to give you that experience that way. Supersize me, if you want to do that one, you can later. We're going to skip ahead just so we make sure we get plenty of time to do both lessons that we're doing. So here, determining sample size. We did this in Chapter 7. What was the sample size needed for certain things to occur? And so with that in mind, when planning a study, we want to choose a sample size that allows us to estimate a population proportion within a given margin of error. The formula for margin of error is a confidence interval of P. Here is what margin of error is equal to. We've looked at that before. The margin of error calculation includes a sample proportion P hat. Since we don't know, sometimes we don't know what P hat is until after the study has actually been conducted. This means we have to guess what P hat is when choosing in, and there's two ways. If they don't tell us a P hat, a sample, two ways we can do it. One for our guess is that we look to see if there was a previous or a preliminary study already done about the same thing we're trying to do. And if that's the case, then I can use that P hat. All right, so, and we're going to see that in our first example. If not, then we can use 50%. We can use P hat as 0.5. And that way it gives us kind of a middle of the road kind of area. If I think about like the elections that we just got through, when they were going out and trying to figure out, well, how many people do we need to sample if we're going to see if one of the candidate, has around 50% of the vote, and because that way we know we're right in the middle. So, and then we want to figure out, we want our margin of error to be within like 3%. Okay. Because having a margin of error too big really isn't going to help us. And so we're going to try to figure out, well, how many people do we need to survey and poll to see if that's going to, for that to happen. So I also tell my kids, when you read situations and they don't tell you that a study was done or you did it in like a previous problem, like this kind of stuff we're going to see, is the context of the problem inferring that, hey, there's a 50-50 situation, like you're going to answer yes or no. Hey, do you want to eat McDonald's? That's either a yes or a no. You're not going to say, that's what your choices are. Yes, you want to go, or no, you don't. Okay? And so there's some situations like that when we look at the context of the problem, we're like, hey, the only possible answer is yes or no. So therefore, my P hat needs to be 50-50 as I do a sample size, as I go to execute this stuff. And that should work most of the time. So let's practice it. Earlier, we did this GSS thing. They found that the P hat was 31%, is what they found. If we calculated out the 768 divided by 2538, it would have been like 0.30 something, and it rounded to 31%. Okay, so we want to figure out what's the minimum sample size if we want the margin of error. If we want the margin of error to be 0.02. Now, they changed the confidence interval for us. We want 99% confidence. When we did this problem earlier, it was a 90% confidence. So we are going to have to do an inverse norm here real quickly to figure out what Z star is. Because again, the formula we're using is margin of error equals Z star times the square root of P hat times 1 minus P hat over N. So we got to do a quick little sidebar thing of an inverse norm. So I need to do 1 minus 0.99 divided by 2, which is 0.01. Sorry, it is 0.01. 0.01 divided by 2, which is 0.005. Okay. So now I need to do an inverse norm. My area is 0.005. My mean is 0. My standard deviation is 1. And then that gives me some really big number. I think it gives me like 2.5758 something. Do I have it? Yeah, there, I got it right there. 829. And that should be plenty. All right, so we want our margin of error to be 0.02. My z-star is 2.575829. And then it's times the square root of 0.31 times 0.69 over n. So there's my setup. Now we get to start working inverse operations to get us to what n is. So the first thing I'm going to do is I'm going to divide both sides by 2.575829. And I'm going to go ahead and divide that out. Then I'm going to leave my decimal in there. So 0.02 divided by that number, 2.575829. That gives me 0.00776444906. That's equal to the square root. I'm going to go ahead and do 0.31 times 0.69. That is 0.2139 over n. All right. Now, inverse operations. How do I undo a square? Or how do I undo a square root? I square it, Mr. Stevens. So now those cancel. I'm going to leave that as a. I'm not going to square it. I'm going to leave. I'm going to let the calculator do it here in a minute. We learned and practiced earlier that when the variable is in the bottom of that fraction, the two things just they just swap. So n is equal to 0.2139 over that big decimal there squared. And that's what I'm going to type into my calculator. I'm going to type in alpha y equals, give me a fraction on top, 0.2139. On the bottom, 0.0077644,906. And then I'm going to square that decimal on the bottom. And then now I'm going to type enter. And I get n is approximately n is approximately 3548.01. We're going to say n is approximately 3549. We're going to round up. Because if I go down to 48, then I'm not going to be 2%. So we're going to round that one up. There's no fast way to calculate the sample size. We got to go through all those steps to get to that sample size. So let's do another one together. Sometimes one is not enough. The taste of PTS. PTS is a substance that has a strong bitter taste for some people and is tasteless for others. The ability to taste PTC is inherited. About 75% of Italians can taste it. You want to estimate the proportion of Americans of Italian descent who taste the PTC. How large of a sample must you test to estimate the proportion is within 4%? So there's our margin of error. Margin of error, we want it to be 0.04. With 90% confidence. Answer this question using a 75% estimate. So they're telling us p hat is 0.75. That's what they're telling us here. Since they're saying 75% of Italians can taste it, they're telling us what the p hat is. So my C level, again, is a 90%. So we can do an inverse norm and find the decimal associated with that one there. So 0.04 is equal to my Z star there times the square root of 0.75 times 0.25 over n. So we did a 90% already, so I'm just going to scroll up and see where I saw that 90% and grab that decimal real quick. It had to be the first problem. We said our Z star was 1.6448536. 1.6448536. All right, so now I'm ready to start working this one. I'm going to divide both sides by the 1.64. And so I'm going to do that on my calculator. 0.04 divided by 1.6448536. That gives me 0.0243182737. That's equal to the square root. Oh, let's go ahead and multiply that sucker out. 0.75 times 0.25 is 1875. What happened around 1875? Or what happened right after the year 1875? Anybody remember? Isn't that right around when the Civil War occurred? Somewhere around that, give or take 5-10 years? 1864. So 9 years prior. So that was close to there, right? All right, so that was what I was looking for, the Civil War. You know, what happened around that time frame? Civil War. All right. All right, now we get to square both sides. And so I have that big long decimal. Squared equals now the fraction without a square root. We're going to trade places and say n is equal to 0.1875 over 0.0243182737 squared. So that's what I'm going to type into my calculator. Alpha y equals 0.1875 on the bottom, 0.0243182737. Square that part, and my final answer says n is equal to 317.05. So we'll say n is equal to 318. So I need to do a minimum sample size of 318 Italians as I go to perform this confidence interval to have a 4% margin of error. That's what that's telling me to do. I need to survey at least, right around 318 or at least 318 people, Italians, to see if that's true. Okay. There's no short way to do that one. Okay, unfortunately, you can't. There's no quick fix in the calculator for you to do that. So we'll give you a moment to make sure you have it. And this pretty much brings us to the end of this section, is what it brings us to the end of. Using the 4-step process to solve it, putting everything together that we've done for the past 3 days, and then now solving for the minimum sample size. Based on a certain margin of error. We're going to get ready to pick up the next lesson, which is dealing with means. working confidence intervals for means.